In this video, we will define reciprocal lattice. Reciprocal lattice. So we have the so-called direct lattice, or also known as real lattice, and this is related to another lattice which is known as the reciprocal lattice. Essentially, the direct lattice is defined by one of its primitive unit cell. Primitive unit cell. Primitive is important here, and that primitive unit cell, as you know, is defined by three primitive basis vectors. Let us call them A1, A2, and A3. So three primitive basis vectors then define a primitive unit cell, which is a parallelepiped defined by these three vectors. So if I complete the parallelepiped, so this parallelepiped is a primitive unit cell. By primitive I mean that the lattice points are only at the corners, nowhere else. So we are not considering body-centered or face-centered unit cells here. So these three primitive vectors are the so-called primitive basis. We call that primitive basis A1, A2, A3. In terms of these primitive bases, we can define the primitive basis of the reciprocal lattice. A1 is star, A2 is star, A3 is star. The primitive basis of the reciprocal lattice. So how do we define this? What is the definitional relation? So relation of the reciprocal lattice basis vector is very simple and is given by AI star dot AJ is equal to delta IJ, where delta IJ is Kroneker's delta, which itself is defined as delta ij is equal to 1 if I is equal to j, and delta ij is equal to 0 if I not equal to z. So this is a compact or short way of giving the relationship between the reciprocal basis and the real basis. If you expand this out, if you write it explicitly, you will have 9 relations. So for example, A1 star dot A1 is equal to 1 because I and j are equal. A1 star dot A2, now I and j are not equal, so it's 0. A1 star dot A3, again I and j are not equal, so it's equal to 0. So this is the first row involving A1 star. I can write the second row involving A2 star as A2 dot A1 0, A2 star dot A2 is equal to 1, A2 star dot A3 is equal to 0. And finally, the third row will be involving A3 star dot A1 is equal to 0, A3 star dot A2 is equal to 0, and A3 star dot A3 is equal to 1. So these 9 relations define the 3 primitive basis vectors of the reciprocal lattice A1 star, A2 star, and A3 star. However, there is a deficiency in this definition in the sense that if somebody gives me A1 star, A2 star, and A3 star, I can quickly use these relations to check whether they form the reciprocal basis or not. However, what I am given initially is the direct lattice vectors A1, A2, and A3, and I need to first construct A1 star, A2 star, and A3 star. So this definition in that sense is not a constructive definition. So we will now derive a constructive relations using these same relations. So construction of A1 star, A2 star, and A3 star given A1, A2, and A3. So let us do this. Now let us first construct A1 star. We see that in this relation, these 9 relations, A1 star is involved in the first row in these 3 relations. So obviously A1 star will be defined by these 3 relations. So we use these 3 relations to define A1 star. So first let us see the second and third relation, that is A1 star dot A2 is equal to 0. This obviously implies that A1 star is perpendicular to A2. This is an important information because it's telling me some information about the direction of A1 star. That A1 star should lie in a plane perpendicular to A2. I also have A1 star dot A3 is equal to 0, which tells me that A1 star is perpendicular to A3 as well. So if I take both these relations together, so this tells me that A1 star is normal or perpendicular to the plane of A2 and A3. Now, a vector which is perpendicular to a plane defined by 2 vectors, we know a special vector which is perpendicular to both A2 and A3, and that is the cross product. So from this we can conclude that A1 star is parallel to A2 cross A3, because that is one vector which is perpendicular to the plane of A2 and A3. So since it is parallel to A2 cross A3, the vector A1 star can be set equal to some multiple k times A2 cross A3. We have not yet determined what is this k, but based on these two relations, I know that it should be some multiple of the cross product A2 cross A3. Now, how do I know what is this constant k? To determine this constant k, so determine the exact length of A1 star, I have this third relationship with A1 star. The first one actually. So A1 star dot A1 is equal to 1. That relation we have not yet used. So we will now use. So A1 star dot A1 is equal to 1, which means if I substitute for A1 star, what we have now concluded, A1 star is nothing but K A2 cross A3 dot A1 is equal to 1. Which means this k is nothing but 1 by, and using the commutative property of the dot product, I can write it as A2 A1 dot A2 cross A3. So if I substitute this value of k1, I now determine A1 star as A2 cross A3 by A1 dot A2 cross A3. So I have actually solved for A1 star in terms of A2, A1, A2 and A3. The reciprocal lattice vector, the first reciprocal lattice vector in terms of the three real lattice vectors. So this is what we wanted, and we can write this in some other forms. So for example, this denominator is also known as the scalar triple product of these three vectors. So I can write it as A1, A2, A3, where A1, A2, A3 scalar triple product with a symbol A1, A2, A3. And if you recall, this scalar triple product actually has a physical interpretation. This is nothing but the volume of the unit cell. The unit cell defined by A1, A2, A3. This is the volume V. So you can write this also as A2 cross A3 by V. So finally our A1 star is simply A2 cross A3 by V. Similarly, exactly by similar argument, A2 star can be shown to be A3 cross A1 by V and A3 star as A1 cross A2 by V. So we have now found a constructive algorithm of how to construct A1 star, A2 star and A3 star. So if I find these three vectors, let us say A1 star, A2 star and A3 star, then in the exactly same way I can construct my unit cell based on these three vectors, A1 star, A2 star, A3 star. So that will be the reciprocal lattice reciprocal lattice primitive unit cell. So the lattice points will be at these points, and of course if I repeat this unit cell in three-dimensional space, I'll get the reciprocal lattice. Thank you.